Morning.
Good morning.
Were you guys thinking I wasn't going to come on for a second?
I was
Yeah.
like, where's Mr. Rosenthal?
Yeah.
I was
Hi, Shy.
Hi.
trying to handle some stuff.
Yeah.
I was like resetting the page a bunch of times.
Yeah. You're good. Hey, the problem's up. A person starts walking, then runs.
Hello.
Wow. Hello. A person starts walking, then runs, then sits down to rest. Sketch a graph. When it says sketch, that's the key thing to remember when it says sketch is it's not a perfect, you don't even need tick marks, okay, on your coordinate plane. It's just a rough sketch. Sketch a graph of the situation to represent the different rates of change. Label the x-axis time and the y-axis distance.
So we have no idea how much the distance like was.
Yeah, it's conceptual only.
Mm-hmm.
You know, and even though you're not taking a state test this year, this gives you an idea of how they ask this question on a test. They would give you a bunch of graphs and say what's happening during these times. So they want
we wouldn't actually like draw it. We would have to like explain what was happening.
Yeah, you can never, on a state test, you never draw anything. It's always multiple choice or even the constructed response, you don't draw anything.
Mm-hmm.
And we've begun. Good morning, everybody. Makeups today are at 2:50. If you participated yesterday in the retakes, I had a good amount of students and it didn't go overboard with that. That was good. Maybe a dozen students retook yesterday. Some people missed the window. I'll maybe do, those people will have to message me. Already a couple of people did.
Wait, Mr. Rosenthal?
Mm-hmm.
Are we supposed? I think I submitted because I retook chapter 6. I submitted it for the chapter 6 retake. Was that the wrong thing?
No, you messaged me. I think I saw your message with the test, right?
Yep.
Yeah, that's right. And I heard what happened. You saw chapter 6 was the one where I had to cut questions off. That's the only one I had to do that on. I put a little message underneath, hoping that people would see it. I know that was tough. I couldn't think of another way to really communicate that. But yeah, only were supposed to do up to number 14, the simple interest problem.
Oh.
So you don't have to worry about how you did on the other problems. I won't grade those other problems.
Oh, okay, good.
Mm-hmm. So makeups are today, and that's just for chapter 8. If you missed chapter 8. If you intended on getting into that session yesterday for retakes and you missed it, message me and we'll see if I can work out another version for you to take maybe after the break when we come back from spring break. So we can work on that and try to get you a better grade on that. But as for right now, it's just today's lesson. Makeups today later at 2:50 to 4:30. You have to post before 4:30. Set an alarm for yourself. I did, because I have to remember to post it, because I could be playing with my kids or doing something and I could forget to post it. That would be a problem. So I have to make an alarm for myself to remember to post it. So you can make an alarm for yourself to remember to get on and go into that Zoom folder and get that retake.
Mr. Rosenthal?
Mm-hmm.
What chapter, what lesson is this?
This is 9-4.
Will we be doing school tomorrow? Because you said it's okay.
No, and yeah, thank you for bringing that up. So this is the last lesson before the break. No school tomorrow, no school all next week. And then the following Monday, we'll start back here on Zoom again. Okay, and we'll pick up where we leave off. All right? The homework, I know Veronica told me that I indeed forgot to post the homework on Schoology, so you weren't able to submit it. I just put that in now. So you guys are welcome to go and put that in anytime today, and that'll be fine. And I'll be lenient with that. Okay, so if you can post your homework, it's on there now. Any other questions before we start? No? No questions? Okay,
Wait, so we have no school for the rest of the year?
what do you mean no school? We have Zoom school.
Like, I mean, like, no, like, physical at school.
It doesn't appear to be. It looks like the governor and
Okay.
all the superintendents of all the districts stated that we will not be returning to in-person school until next school year, which is in August.
Wow.
That is so.
I know. But
That's-
you know what?
That's crazy.
It is. It's just something else. And, you know, nobody, even the adults, nobody's been through anything like this. We say it's unprecedented. So we're all learning how to adapt. And that's what human beings do really well. We adapt to what's going on around us. That's why we've survived for a couple 100,000 years now.
Unless you're really old and you lived during the Spanish flu in 1920.
Well, I don't think society did what we're doing now during this.
It was 1918, actually.
Close enough.
He actually survived.
So yeah, I mean, there are people that are 102, 100, 300. There are some people, but they were just born. That you
There's
could
a
talk
person-
about how would they have experienced that, and did they do what we're doing now? Did they quarantine in America the way that we're doing now? I don't know. I don't
I
think.
think they were just carrying on with daily life, and they were like, "Oh, someone just got sick."
Yeah,
There's a
It was actually illegal in some cities to cough in public.
some people could look up now on Google about germ theory. When did germ theory come out? It might have been in the late 1800s. So if germ theory was a new thing, you know, they didn't realize how people got sick. They just saw people getting sick. They might have had all sorts of reasons or rationales for why people were getting sick. All right, let's get to the lesson. Let's take a look
There's
at.
a woman.
So you have this quadrant 1 coordinate plane. It says label the x-axis as time and the y-axis as distance. Okay, so if somebody is walking, a person starts walking, then let's say at 0 time they were starting here at 0, 0. Let's try to understand walking. Let's say a unit of time goes by. Watch my marker carefully. I'm moving over. As time goes by, the person's distance doesn't stay at 0. They're walking. So it needs to travel up at the same time you're going to the right. Think of an Etch-a-Sketch. So time goes by, but I have to increase my distance from my starting point, also known as displacement. Okay? So if, let's say I stopped, take a picture in time, freeze frame in time, then I would have gone through any 2 points. There is exactly one what?
Line.
Line. So this would be a graph maybe of somebody walking. Okay? All right. Then the person starts to run. What happens? What's the difference between running and walking?
You go farther
You
distance.
go faster.
Yeah, you go like
The same
you go faster in less
In the
time.
same amount of time, you're going to go a further distance. So let's say I go for the same amount of time. So here I went that far. Now I'll go about that far again, right? As I'm going to the next marker, I'm not just going to go up in the same walking path. I'm going to have climbed steeper, right? So it now looks like that. Okay? And then sits down to rest, stops moving. What is going to happen now? This might be the most.
The distance is gonna stay, but you're just gonna like draw a flat line
Exactly. You totally
He's
got.
not moving over time.
because nothing like the distance and the time, neither of them decreases.
But time doesn't stop, does it?
No.
So you must keep moving to the side in time, but you're not changing your distance.
Yeah,
Is this a function?
I think so.
Yeah.
Because
Is it-
there's no point above Or yeah, that's a function.
Are you
Yeah,
in two
maybe.
different are you in two different distances at the same time?
No.
No, so it's a function. Okay? All right. Any questions
Yeah,
about
I did it right.
Good. That means you have an intuitive understanding of this. That's
I
good.
also did.
That's evidence of growth. That's really, really good. Okay, next one. Determine whether the following statement is, oh, I love these. These are hard. Always, sometimes, or never true. These are really deep questions where you have to really try to think of all the cases and try to find a counterexample. Justify your reasoning. Okay, a linear relationship that has a constant rate of change or a slope is a proportional relationship. Oh, I think we already can answer this.
Always.
Oh, always. So if it's linear with a slope, it has to be proportional, right?
Yeah.
So I can come up with a counterexample, but I think I'd rather you come up with a counterexample. Who can counter that argument?
What is your argument again?
As long as it's linear and has a slope, constant rate of change, it is a proportional relationship. Can somebody explain on this graph how I can show otherwise?
If it doesn't go through the origin.
What's it?
If the
you have to
linear
Don't
relationship.
start at the origin.
So this.
If there's a plus b.
Yeah.
This has a slope. Rise
Mhm.
over run, rise over run, rise over run, a constant rate of change, slope, up and over, the same amount. So it's a line. But this is not proportional.
It has a y-intercept.
Well,
Y-intercept isn't 0.
okay, let's be careful. Yes, I know what you mean. You mean the right thing. But even if one is proportional because it starts from the origin, it still has a y-intercept. It's just the
Yeah.
y-intercept is 0.
Oh, since the y-intercept is 0, that's what I mean.
Right, yes. And so if the y-intercept is anything other than 0, it loses its proportional relationship. And what are they?
Because it
So
can't be.
what are the consequences of that?
You're not proportional.
All right, it's not proportional. And so what are the consequences of the points, the x's and the y's?
It makes it harder to do it.
What do you mean?
I'm just coming up with things.
Okay, and anything else?
Not
What are the
probably.
It
consequences?
requires a like for the equation, or because it requires a y-intercept.
x1, y1,
Mm-hmm.
x2, y2, x3, y3. What are the consequences when it's not proportional versus these x and y's along this one?
You have to add or subtract something.
So what is slope?
I mean,
Slope is delta
slope, it's a
change in y over
over
change in
change
x.
Oh.
So that could be the same for both of these. These both are linear patterns. They both have a slope, right? So we were saying that, they were saying that, well, if you have a slope, it's proportional. Well, sometimes it is, if it goes through the origin.
Yeah.
What's the same about them is that they both have this, a constant change in y over change in x. They both have that. What does this have that the other one that's not proportional doesn't have? What's the
The
consequence?
change in y over.
Proportion.
Well, I mean.
What? Okay, go back to the definition
Yeah.
of proportion. What is a proportion?
Something
Two
that
ratios that are equal. Two ratios.
Ratios are equal. Ratios of what?
Ratios of
X and Y.
x and y.
Y over x.
Y over x.
All of these points, the y
Are
over x,
equal. They're equal.
all the y's over x's in all of the points are equal.
Yeah.
What about this y over this x? Is it equal to y2 over x2?
No.
No.
Equal to
No.
y3 over x3? No, that's the
No.
consequence. These ratios are not equal. Y over x, y over x, y over x, they're all different. But
Because
along this one, when it starts from 0, all the y's over x's are all equal to the slope.
and the equations are different because when there's a proportional linear relationship, then it's y equals kx. But when it's not proportional, it's y equals mx plus b.
Yes, and that's just so that we can name proportionality. When you see a K, that lets the reader know that we're talking about proportionality. Great, excellent.
If it's a parabola, could it be linear or?
If it's a parabola, it is not linear.
Because
Oh,
and
oh, yeah,
also
'cause
the
it's not
equation
line.
for a parabola is y equals x squared.
Do you guys know what a parabola is?
Yes.
What is a
It's like
parabola?
a U. Well, it's like a curved shape.
It's when
What's the
it's
definition?
when I did this. It was like when 2 points can connect with equal distance. When points connect with equal distance from each other,
Not
and
points.
it's like
Okay,
I did this.
you need a point and a line to make a parabola.
Yes.
This line is called the directrix. This point is called the focus.
Oh yeah.
Okay, so a parabola in a plane. We're in a
It's like
plane of the board here.
Something
A
to do
set,
with
a set of
squares.
all points. The parabola is made up of a set of infinite points that are all what in common? They're all equidistant from both this point
from the line
and the line.
Yes.
All the points equidistant from a point and a line. So how do I determine that? Well, if I go straight down, then the midpoint here, that's the same distance, right? But what happens when I come away, right?
It's not the same
This
distance.
point, if I go straight this way, this is straight, this is diagonal, so these are not the same. So in this one is longer than that one. All right, so what I have to do is I have to shorten this one and lengthen that one. So this point comes up a little bit, right? And then the further I move out here, right, to some point, that point, I have to find where this to there is the same as that to there. So that point comes up, and look what happens to these points.
Ta-da.
And on the other side. So you get the set of all these points that are the same distance from that point and this line, it looks like that. That distance and that distance. Okay? And
I
this
remember, yeah.
and that distance.
You gave that like assignment like one time and then like
Mr.
yeah.
Rosenthal,
Yeah.
what makes a linear relationship proportional?
That it comes from the origin.
Oh, okay.
Mhm.
Okay.
Like
And
if
one way
keep-
you can experiment with that, Charlie, is to have a table of values where you don't start at the origin, but when x is 0, y actually has a different starting number. So it's, let's say, 0, 1 even. Now have the same change in y. I'll let you pick the change in y, Charlie.
3,
So what's 1 plus 3?
4,
What's 4 plus 3?
7,
What's 7 plus 3?
10,
Okay, now you also pick the change in x. Keep it simple.
5.
5, 10, 15. Okay, now make a fraction out of these. Y over x, y over x. 4 over 5, 7 over 10, 10 over 15. Are any of those equal?
No.
So it's not proportional.
Okay.
Now, let's do the same experiment, but start at 0 and have the same change in y.
There we go.
Now change the y by 3. 3, 6, 9. Now let's look at your fractions. 3/5, 6/10, 9/15. Are those equal?
Yes.
They are. So because they
Yes.
started, because x and y started on the same level playing field, when they increase by the same amount, it's the same as me taking this fraction, right, and multiplying by, let's say, 2 over 2. What is 2 over 2?
1.
1. So the what property gets employed here?
The identity.
Identity. You're
What
multiplying by
property?
1. What is the significance of the identity property? Is when
Very
you multiply by 1.
When you multiply by 1, it's then
You can
it's
change
the
how it
value
looks, but you
ends
don't
up
change the
self.
value.
Yes,
Yeah.
and so the result is equal. The result of doing it is equal. And now you can go ahead and multiply. So that tells me that this is equal to that. And when two ratios are equal, that's the definition of a proportion. Okay?
The 2 ratios are
Yeah. So go back to the beginning.
Wowzers.
What gave us that situation is when we started with x and y in the same place. Okay?
Okay.
All right. Let's go. We are Doing a lot of great things so far already. We just started. Okay, let's go to our next one. Okay, I gotta shrink this a bit, maybe slightly. Let's go to 225 and see what that looks like. Yeah. Okay, this might be fun. This might be a challenge for you guys. I want you to try to do this. I'll read it out loud. Why don't you just start with A? Let me bring that down. Okay, so now an extension ladder. You can draw this diagram on your paper. Have fun with this one. An extension ladder has a, that means the ladder you can extend the height of it. Has a label that says, do not place base of ladder less than 5 feet from the vertical surface you're trying to climb up. Don't place the ladder less than 5, the base of the ladder 5, don't less than 5 feet. Why not?
Then it can fall. It can fall because
Yeah, if you pick a ladder
slope.
too close to the wall that you're trying to climb up, it can tip back over. All right? So you can try to draw that. What is the greatest slope possible if the ladder can extend to safely reach a height of 12 feet, of 18 feet, of 24 feet? Try that. See if you can do that. You guys can talk to each other, but one at a time, to try to help each other. This is where I should use Zoom's breakout sessions and put everybody in like a group of 5, you know?
Can you?
Yeah, that's what I just put into the chat.
Can you?
Yeah, you guys can just put it in the chat, but you guys are welcome to talk to each other.
Or can we go into breakout rooms?
I've never done it.
I wanna.
I think we
Says
should
create
just do it.
breakout rooms.
Sanders.
I don't have it.
Sanders does it all the time.
I know, but he put it in his settings. I didn't put it in the settings when I would have to change the settings, and I'm not going to do that right now.
Oof. Oof.
Homework is due today, right?
Mm-hmm.
Good.
I like to draw the ground and some surface I'm trying to climb, some wall.
Oh, and Mr. Rosenthal,
Mhm.
I don't think you put up the page 400 homework on Schoology yet.
Yes, I did.
He did, I just checked.
You did?
This morning I did, like 20 minutes ago.
Okay.
Oh my god.
Somebody stop that.
Somebody's trying to
Mute
indefinite.
your mic if you're not going to contribute to the lesson. So the ladder can be placed anywhere this way. You might want to think of some different starting locations. What if the ladder starts at these different locations? What happens to the slope if I'm trying to get there?
What is going on?
Bad stuff.
Which slope is the steeper slope? The slope that is closer to the wall or the slope that's further from the wall?
Closer.
Closer.
The closer I move the base of the ladder to the wall, the steeper the slope. So if I want the greatest slope, where should I move the base of the ladder?
The closest
2 5
possible
feet.
to the
5 foot mark, right there, right? If I'm following the safety standard. Now, if I didn't follow the safety, then you would want it, what would you have? You would have an undefined slope, would be the ladder is embedded in the wall, and it would go straight up, right?
That would choose
Yeah.
the greatest height.
Okay, but hold on.
Divided by
What's
5.
the greatest slope possible if the ladder can extend to
34
safely
divided by
this height?
5.
So you would want to go here to 5, and then this is 12, all right? So what would be the slope? What's the slope? What is this slope in numbers, using numbers? What's that slope? If the ladder is
12 over 5. 12 over 5.
the rise over the run. Where did my feet go? How come I don't have 12 feet over 5 feet?
Because the feet cancel out.
Yes,
The
feet
feet
over
cancel
feet,
out.
dimensional analysis. Feet over feet, the feet cancel out, good. What if I was trying to reach a height of 18 feet? How would that change the slope?
18 over
18
You got
over
it.
5.
And then 24 feet.
24 over 5.
Those are my different slopes. Okay. Any questions about that? Let's go to part B of this then.
Mr. Rosenthal, how'd you solve that again? Did you do division?
No, like,
I didn't do any division. The slope is written as a fraction. It's a
Oh.
ratio of delta y over delta x. My height has to change by 12. My x distance is 5.
Okay.
Okay. Let's look at B. Once when the ladder reached 20 feet.
tomorrow.
You guys, mute your mics, please. Once when the ladder reached to 20 feet with the base 5 feet from the wall. Okay, let's draw that. So we're 5 feet from the wall and we have a height of 20 feet. It slid down and away from the wall until it was flat on the ground. Oh, okay, so the ladder slid down. Everybody probably has seen. You guys, when I'm in the middle of a sentence. When I'm in the middle of a sentence, please don't talk. Okay, I have to wait until you guys are getting the message. Maybe you don't hear yourself. You guys need to mute yourselves, okay? Because I think you don't even know you're talking and it's interrupting the lesson.
Just mute yourself.
Okay. All right, so here we go. Nobody's talking. And if you are talking, that's fine. Go ahead and mute yourself. We don't want to hear any sound. Not getting it. Okay, I think I have to try to mute everybody. Let's see. Manage participants. Mute all. There we go. Okay. Everybody's muted. Hopefully you can hear me. All right, and now if you unmute, that's fine. You're going to say something, that means. But you're waiting for me now. All right, so now the ladder is going to slide down the wall. So that means this part the base has to slide out until the ladder lands flat on the ground. So this point is going to slide out this direction until the ladder is down on the ground. Okay? What slope values did the ladder have during its slide? Now you can unmute.
It'll be 20 over 6, 20 over 7.
Can we start with the initial one? What was the beginning?
20 over 5.
Yeah, it started
Well,
at
it's
20 over 5. But
Just
you have to
4.
understand, it's not going to be 20 over 6. Why not?
Because the height of the ladder is going down.
Oh, because it's going down every time.
Yeah.
So it goes down.
Let's say that that's the next one, right? So let's say let's say that a foot down gives you a foot out. So how about 19 over 4? No, and excuse me, 19 over 6.
Over 6, yeah.
18
So it goes down
7.
So as y decreases by 1, x increases by
by 1.
Yeah.
Okay, and then 17 over 8. Right? When does that end?
16. It would end when y is 0.
Yeah.
Okay, so this goes all the way down to so this has to go down to 1, so minus 16 plus 16, right?
Yeah, so 1 over 24.
Minus 16 is 1, plus 16 is 24. Right?
Well, wouldn't it have to be completely on the floor? So
that's not completely on the floor. So what have we missed? We've missed all the in-betweens, right?
Yeah.
Okay, so what is this? What is the biggest slope that I have? Is 4.
Yes.
Okay.
So
what happens when this gets to 0? Does it matter what my bottom number is? 0 out of 25, right?
It would just be, it would be
to 0. So it's going to travel from 4 to 0 and everything in between. So my slope has to be between, including 0 and, see how I put equals? Because it can include.
Because it can be 0 or 4.
Yeah, so the slope when the ladder is flat is 0. So m can be 0. The slope when it was at its tallest was 20/5. So that's 4, but it can't go above that. And then as it slid down, it went through it started to flatten. As the slope flattens, that number 4 goes down, 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 down. What is 19/6? It's 3 1/6. This is 2 4/7. This is 2 1/8, right? And so on and so forth, till you get under 1, right? 1/24 is less than 1, okay? So the slope is flattening, is what's happening. As the slope flattens out, you're approaching 0, and then when the ladder's on the ground, the slope is 0.
Yeah, because
Okay?
it's completely flat.
Because it's completely flat. That is a great problem to think about slope. So you guys, we're building this conceptual foundation for you of how rate of change works, of how slope works, and how that's built. Okay. Moving along. Okay. Next one. Are these points on one line? Explain and use the definition of slope. So you have these 3 points. Try to start looking at them now, and I'll put them on the board. Are they on the same line, and how do you know? You can't just say it looks like they are. You have to be able to give me something substantial, a substantial reason why you know these points are all on the same line, or you know that they're not on the same line. Take a minute, go. You can talk to each other. And while you're working on that, I'll do a little attendance check.
Bless you.
Again, anybody who joined us late, our makeups for the chapter 8 are today at 2:50. Set an alarm for yourself so you remember, so you don't miss that window. If you miss the window, I cannot help you. For those of you that missed yesterday, you need to message me, and we might be able to work out some sort of third version of the test that we can do after the break. All right, attendance looks good. Oh, we had 56 participants. We somehow can't get over that 60 mark. Call your friends that you know are not on. The ones that like to join later, tell them to come on. It's better live. You can talk to one another. It's good for your social, emotional, during these tough times, to be able to hear each other's voice and feel somewhat of something similar to a classroom. So,
I haven't seen a human beside my family for the past 2 weeks.
If
What?
anybody in the future is watching this on YouTube's, join the live.
Yeah.
In the future,
Do it immediately.
all right.
Mr. Rosenthal,
Join
I
tomorrow.
found
Subscribe to Dizzy Dude.
Are you guys, go ahead and mute, unless you're asking me a math question. We're trying to figure this one out. Come back to focus on this.
so I found the constant rate of I found the slope between the first 2 points,
All right.
and then
Oh, yeah,
I did.
We're 2.5 minutes in, so we're just going to stop and discuss now anyway. So go ahead, Jasper. What was your rate of change between the first 2 points?
So my rate of change between the first 2 points was -2 over 2.
It goes down. That one goes down 2, and this one goes up by 2. So it was what?
So it would just be -1.
-1. Any questions about that? Then what did I do?
So then you what I did was that I filled out the table after 1, 1. And then I try to find if
Okay.
10,
See if that falls on that line.
yeah, but you can also do it a different way.
Anybody else have any other ideas?
I just took a rate of change from another coordinate pair.
Like which one?
Like 10, -8. And oh wait, I think I did it wrong because then I did -1, 3 to 1, 1, and then I did 1,
You got
1
that.
to
That's green.
yeah, but then I did 1, 1 to 10, -8. So
Great.
that would
That's
be
perfect. That's what we want to do. Okay.
oh.
When you go
Okay.
from 1 to -8, you dropped by 9. And when you went from 1 to 10, you increased by 9. And so your rate of change simplifies to?
-1. They're both equal.
All right.
On the same line.
So if the rate of change is constant, then guess what you know about these points?
They're on the same line.
They have to be on the same line.
Yes.
Yeah, they have to be on the same line. Okay? So any questions about that? Remember that on a line, given a line, the rate of change between any 2 points on the line is constant. What if I did the rate of change between the first point and the third point in purple? To get from 3 to -8, how far do you have to drop?
11.
You have to drop 11. And then to get from -1 to 10, you have to increase by 11. So it's not a coincidence. Along a line, the rate of change must stay constant. Okay? So if I use this point with that point and the rate of change is the same, then if I go from this point to that point and I still drop down the same amount, then that means I've stayed on the same line I started on. Okay? All right.
So you have to find the slope between all of the different points and then realize that they're all the same.
Did I need to do the purple one once I found the blue one?
Mm-hmm.
Did I? You think I do? Is it possible for green and blue to have the same rate of change and for purple to not work out?
No.
No, because they're both increasing by
If I start at red,
what is it called?
if I start at red and I drop down to green, and then I want to drop down to blue, and when I drop down to blue, I follow the same drop and over that I do here. Well, if I follow the same rate of change to blue, then guess what? I'm traveling along the same path. I'm traveling along the same line. That means that I don't now have to determine that from red to blue is purple. I already know it's going to be because it traveled through green to blue. Okay? All right, next problem, we're going to see what your algebra skills look like with slope. So now you're going to put together, if you really now deeply understand slope, and you're comfortable with no numbers and just variables only, you should be able to do this one. I'll read it out loud and we'll take a look at it. A line contains points PQ and it also contains QP, right? And that could be any numbers that you want to put in there, any real numbers. But P cannot be equal to Q in this example. What is the slope? Do that now. Take 30 seconds to see if you can write the slope. Go.
What's a slope?
Change in y over change in x.
Made absolutely no sense, but thank you. you got two y coordinates and you got two x coordinates. So do the first x minus the second x and the first y minus the second y. Okay.
And
I
what,
think
So is that
no,
this?
it's the other way around. It's second y minus first y.
I
then-
mean, you can do it either. It's the same thing because it's magnitude.
right.
Okay. Can you do this one?
what is slope? What is slope? That's the question. I mean, that's such a key element of this chapter that is the question of the chapter. What is slope? And we're looking at slope in so many different ways to try to understand what it is deeply. Simply put, slope is a rate of change. It's how something is changing when something else is making it change. And in order for something to make something else change, it itself has to be changing. Okay, so now that could be confusing, but as time changes, your distance changes. As time is an easy way to think about slope. As time changes, the world moves, doesn't it, Everett?
Yeah.
Okay, the
As
world
time changes, people play.
If time stops, now we're talking about a photograph. In a photograph, time is not moving.
Huh?
Time in a photograph, when you look at a picture, that is a moment that captures a moment in time.
Yes.
Okay,
Or a time capsule.
so that is a location in time of where everything is. Everything's position at that moment is captured in the picture.
Yeah.
But that is not capturing rate of change. That's not capturing slope. Slope has to do with, as time is moving, how
things change?
How are other things changing? And so you can find the slope of all kinds of things. You can find the slope with respect to distance over time. Changing your distance over time is what speed is.
Age over time.
Velocity. Age over time, you can get a slope. The amount of money you have in a bank account over time. Okay, so time is, but it doesn't have to be.
Heart speed over time.
It doesn't have to be with respect to time. You can do volume to area. How does the volume of something change as the area is changing? How does the volume of a sphere change as you change its radius? Okay.
What do you mean the radius? What do you mean radius?
The radius of a sphere is the length from the center of the sphere to the outside. Like the radius of a circle. How does the area of a circle change as the radius changes? That would be a slope. So how one thing changes because you're changing another, that gives you a slope. So if you ask what slope is, now you can use time is a good way, but it doesn't have to be. But you can think of all these real world examples of change. And then this is good for everybody to hear because it opens up your mind to all the possibilities of what you can study when you understand slope. Epidemiology, spread of the virus, exponential growth. We know that it's not following a linear path. Okay, so
what does that mean?
Well, linear is what we're studying, that it changes in the pattern of a line. The rise over the run is constant. That means every day the same amount of cases pop up.
No, it's gonna be more of a curve because as more people get infected, the higher amount of cases there will be every day.
Right. And so what comes after studying the linear is studying these types of curved exponential changes. So that's what's next. But we have to first study the simple, which is this linear stuff. But what's cool is in algebra 2, you'll study the curved pattern, exponential growth like that. But in calculus, what you'll do is you'll bring it all the way back to what we're studying now, which is that at any one snapshot in time, let's say that at that time, you can then find out how much was it increasing in a linear way at that time. That's instantaneous change. What is the slope in that moment, in that photograph? How was it changing at that moment is not curved. It's linear, okay? So That's what that's called a tangent line. The slope of the tangent line is what we call in calculus the derivative. All right, let's take a look at this problem now. How is this coordinate changing to that coordinate? Well, the way, Everett, mathematically we determine how a 2 goes to a 10. How does 2, Everett, go to a 10? You take the 10 and you subtract the 2. And we now know it changed by 8. So
Yeah.
we captured change mathematically by subtracting. So guess what I'm going to do with my variables? I can find, remember, this is x and y, 1, and this is x2, y2.
Yeah.
I can take my p and my second y and subtract my first y to find out how my y changed.
Oh my God.
P minus q.
Okay, that's crazy.
And then x is changed. So we want to talk about how did x change. X is usually time. Q would subtract by p. So you can write it that way, but that is not simplest form. Did anybody
Yeah, you have to
further than this?
Yes.
Yes?
Yeah.
I plugged in some numbers, and it turns out that every single time it turns out to -1.
Yeah.
That is beautiful that you did that. So they're going
Yeah.
further with this. They're plugging in, let's say P is 2 and Q is 3. 2 minus 3 and 3 minus 2 always give you what? Opposites, right?
Opposites. And
Yes.
so put them over each other, you're
it's
going to get -1.
Nice.
Right. And so if I were
Or
to
the
have done,
same numbers.
so somebody said, what if it's x1 minus x2? What if you switch these, but you also switch the y's? y1 minus
Same.
y2.
The same.
You're
That's
still
what
going to get
that's
opposites.
what I did yesterday.
What if I switch one but not the other?
It's going to be +1.
Right, and you won't get the same answer. So you can go either way, but either way, it doesn't matter what's correct, but you have to be consistent. Okay, if you do x1 minus x2, then you have to do y1 minus y2. If you do y2 minus y1, then you got to do x2 minus x1. You got to go the same direction. Okay, so how do I get to that algebraically? Now I'm going to teach you guys how to link this to what we learned about factoring. How do we factor something like this? So let's take q minus p. Watch this, everybody. I want to show you very carefully here. Okay, what is in common with the variable q and the variable p? I'm going to try to factor out a common factor between q and p. Does anybody see a common factor?
No. I
If
mean,
you don't see a common
there's
factor, then it's what?
1.
1. 1 goes into q and 1 goes into p, right? So if I pull out a 1, is this still the same as how I started? 1 times q minus p, is it still q minus p?
Yes.
Okay.
Yes.
What if I pull out a -1? -1 times what gives me positive q?
Negative Q.
Negative Q.
Negative q. Let me just check on this. -1 times negative q is positive q, correct?
Yes.
Okay, let me bring this up here then. -1 times negative q will give me the positive q. -1 times what is going to give me negative p?
P.
Plus p, right? Yes or no?
Yes.
Yes.
-1 times positive p is negative p. Okay? Is addition commutative?
Yes.
Yes.
Okay, so you just do that. Let's use the commutative property to switch these. P plus negative q. Okay? Now wait a minute. Can I write this as p minus q instead
Yes.
of what? Okay.
Yeah.
I'm transforming this, but I'm not violating any rules. Okay, so that means this is equal to this equivalent expression.
Yes.
That means I'm going to go back in here, and I'm going to pull out this, and I'm going to put in what's equal to that. You said that p minus q is the same as 1 times p minus q, right?
Yes.
Yes.
Now I have a product of two things. Here I have a product of two things, and this thing is the same as this thing. So they cancel. leaving you 1 divided by -1, no matter what P and Q are, as long as P is not equal to Q. Why did we need to say that? What happens if P and Q are the same number?
Then they become 0.
It's 0 in the denominator, so we want to avoid that. So as long as P and Q are not the same, they will cancel, and you'll get 1 divided by -1 is -1. That is the answer. Any questions?
So in this problem,
Process again, because I'm kind of confused about how.
what? So in this process, you have to find a way
Factor out
to.
a -1.
Try to look again. I know.
This will be useful in algebra when you're trying to simplify large rational equations with denominators that are complex. You'll be able to learn something here. What did I learn? I could switch the order that I subtract if I factor out a -1. If I need the top to look like the bottom, but the Q and the P are switched, I can get them to switch back if I pull out a -1. That's a little tool that you can put in your toolbox. I can switch subtraction if I factor out a -1, and I showed you that process right here, step by step.
What if on the problem where they're both being multiplied by 1, what if P was negative?
Doesn't matter, then it's negative down here as well.
Oh.
All right, moving on to the next concept. Good job, everybody. I'm hitting you with a lot of heavy concepts now. These are not light. Chessboard, yay. Okay, I think I need to shrink this down a little bit to fit. So let's go to 200. Yes, that's good enough. Okay, in the chessboard drawing, the knight, so people that understand chess already know this, but there's a lot of people that don't know how to play chess, they don't know the rules. The knight is people would say, is the weirdest moving piece. This knight can move to any of these white spots. That is how the knight moves. It cannot move diagonally. It cannot move left or right. It cannot move up or down. It has to go to and over. So it can go 2 in any direction, not diagonal, 2 up, 2 down, 2 left, or 2 right. Okay, and then it has to go over 1 perpendicular. So if I go 2 up, I can go left after that 1 or right. If I go 2 to the right, I can go up or down 1. If I go 2 down, I have to go left or right. If I go left 2, I have to go up or down 1. That is how a knight moves. If the beginning and the end squares of any move determine a line, what slopes are possible? Go ahead and jot them down.
A lot of slopes are possible.
Okay, just write them all down for me, please.
How?
Just write the slopes. Count every square as a unit.
Oh.
Take a minute.
Excuse me, Mr. Ronto.
Mm-hmm.
Don't we need 2 dots for the slope?
Not 2 dots.
It's like several dots.
A knight and a dot.
Excuse you, Andy. Okay.
You know, like night and distance traveled, or something like that, or a night and dots traversed.
Yeah, the knight will be here and then it will be there. The knight will be here and then it will be there. It's the change. It's the change in the position of the knight over moves. Over change in a move.
What lesson is this?
Actually, no. It's the change in vertical squares to the change in horizontal squares.
What lesson is this?
It's for you guys. The question of what lesson this is, I don't know how I feel about it. I don't know why it irritates me, but it does. I'm so sorry to say that. It just is. I don't know why it does. I don't. I think it matters if. I think it does matter. I think you want that. I'm guessing you want to know because you want to know organizationally where to put it in your notes, or you want to be able to print out the lesson or look it up, something like that.
I always title the pages in my math notebook what lesson we're on, so I know what we were.
Yeah. But I want you guys to be responsible for knowing where we are.
About how much homeworks you get.
Yeah, we go in a linear fashion. Now, after 9.3, we go to 9.4. After 9.4, we go to 9.5. You guys can do that part. But you know what? I'm sorry. You go ahead and ask me if you want to know.
Mr. Rosenthal, I put what I got in the chat. I don't know if it's correct though. I counted each square as a unit.
Well, it's been 2 minutes, so let's go over it. Okay, so let's start with this one.
Abby?
This slope here is up 2 over 1. So that's my first slope. What about this one? Up 1 over 2. This one is down 1 over 2. This one, down 2 over 1, which is just -2. So that you can just put as 2, that you can just put as -2. Now let's go over to this one. This is down 2 to the left 1. Down 2 to the left 1. Well, wait a minute. That's 2, and we've already done that one. This one is down 1 to the left 2. Down 1 to the left 2. Well, that is just 1/2. We've already done that one. And if you see, up 1 over 2, and then down 1 to the left 2, look at those. They're in line with each other. So it makes sense that to go from the night to that dot is the same slope as going from the night to that dot. They're along the same line, so they have to have a constant slope.
Yes, they are.
So if this night makes a line with 2 dots, then this being down 1 over 2 has to also be the same as this one.
The opposite side.
Up 1 is +1, to the left 2 is still -1/2. It's still the same as going
thing.
down 1 over 2. Up
They're
1
optical
left
to
2
each other.
is, yeah, so these are the same slope. This one is the same slope as this one. This one was down 2 over 1, which gave us -2. Okay, so going here, up 2 is positive, to the left one is negative, is still going to be -2. Okay, so these have the same slope. Okay, so that's what helps. That helps us see that connection.
I'm not gonna sacrifice my night anymore.
Everett, please stop with your camera.
Yeah, do not post the video. This is recorded. So for the security of our Zoom lessons continuing in a secure fashion, never post your videos.
Okay.
Any reason. Okay? All right, moving
Mr.
on.
Rosenthal?
Yeah.
So so on the chessboard, the lines that connect up and down, like the ones that the 2 top ones and the 2 bottom ones that connect to each other, those wouldn't be a function, would they? Oh no, they could connect across. Never mind.
Okay, so you're saying up
yeah.
and down points, but you have to connect using the night. The night must be used. You can't just do 2 points to each other. It has to be from the night to the points.
Yeah.
Yeah. Okay?
Mm-hmm.
All right, so we are at a good stopping point here because now we start direct variation. And direct variation is just a way to talk about proportional linear equations. That means they're all, in this section, they're all going to come out of the origin. So it makes everything actually much easier. So this lesson is going to be an easy peasy lesson, but we're not going to do it until after spring break. So at this point, I'm going to say, don't miss the makeups today, and enjoy and be very safe. Take care of your social distancing. The more everybody social distances, the sooner we can get back to a normal world again. So please, everybody do their part in that. Okay, and then that being said,
Mr. Rosenthal.
I'm going to stay on for office hours as I always do.
Hi, Mr. Rosenthal.
All right, and see you later if you're going to go. And then I'll see you not next Monday, but a week from next Monday. All right, you are dismissed.
Rosenthal.
Thank you so much, Mr. Rosenthal.
It's so.
If I get kids, I'm going to exaggerate this so much.
Is anybody Is anybody staying on for office hours?
I am. Mr. Rosenthal.
Page
Mr.
400.
Rosenthal.
You didn't put it
Thank
in
you.
the
Rosenthal.
homework to submit yet. Page 400. You didn't. Are we supposed to turn in page 400?
Yes, please.
But you didn't put it in the
I
homework
did
yet.
put it in.
Yeah, I did.
We did it.
Oliver, you have to just reload your Schoology.
Okay, I'm gonna check.
Mr. Rosenthal.
Uh-huh.
So when you're talking about factoring like equations where there is like when you can't really tell if there's anything in common, so you always try and like factor out a -1 like all
Yeah,
the time
so
if it's subtraction.
Jasper, where you
Okay, thanks.
are,
I found it.
when you're making
Happy
your way,
Easter. Goodbye.
bye. So Jasper, when you're making your way through that green algebra book,
Yeah.
you're going to get into the later chapters eventually where you're trying to simplify these types of expressions.
Yeah, I was in chapter 12, and then it was it was using factoring to solve equations.
What if I have this?
Mm.
2 minus that. Well, now you've learned what this is going to come out to, right?
Yeah,
This comes out to -1. So 2 minus -1 is 3.
3.
But you would need to know that trick. So you would need to
Yeah.
rewrite this as a minus b, and you see, oh, these look really similar. If I could just find a way to make that a minus b, I could cancel out the a minus b's. And we just learned that. It's by factoring that out and treating this as a group times 1, right?
Yeah.
Okay, so then you get that. You get that this becomes -1. So you get 2 minus -1. And that's 3.
Are there any other tricks to like use factoring when solving equations when they're
Oh yeah.
when like yeah, because I wanted to know some of those tricks because like if I have an equation that I'm stuck on.
How are you going to do that?
So
Common denominator.
yeah, it would be C, A, B.
And I'm really multiplying by 1, aren't I?
Mm-hmm.
Yeah. But what this does is it'll give me the same denominator. And so 1 times c plus d is c plus d plus 2 times a, and so you'll have 2a plus 2b all over 1 denominator.
AB times C, D.
Yeah.
Could you factor?
Then, yes, then you're going to get into a situation where now all of a sudden, this is one of those, yeah, this is a quadratic that you can factor.
Yeah.
And then you'll see when you factor it, one of these comes out to, let's say, c plus d, and you get rid of it, and that's it.
Yeah.
Yeah, you got it. You are totally following.
Yeah.
Does that make sense?
Yep.
Yep. Now, be warned.
Mm-hmm.
When you're talking about domain and range, about what x can be, and let's say there's x in here. Let's say that this is x plus 5. You have to make sure that you realize, even if you cancel out the c plus d part, you have to make sure that that can't be 0. All right?
Yeah.
So if this is x plus 5, you have to make sure x is not what?
0. It was 0 because
it can't be -5.
-5 because that would be 0, and then
right. So then maybe you do the canceling, and that allows you to solve something. But what if what you solve has 2 answers and one of them is -5? Then you have to say, well, I got a -5 mathematically, but it can't happen in this problem.
Yes.
So that's called an extraneous solution. And that can sometimes happen.
So it can't happen in a solution, but like what you solved was
because I canceled it out.
Yeah.
Then it came out of the problem, and I was allowed to solve. But you in order to get that, you'd have to violate. Hi, Jack. You'd have to violate the fact that the denominator became 0. So you have to remove. So that you know, that came out to maybe -5 in your answer, hypothetically.
But it can't
be that. But it couldn't be your answer. So that could happen, and it will happen when you get to algebra.
All right. Can I copy this down?
Please. take a picture, just do a snapshot on your
Oh
computer.
yeah, I forgot about that.
Yeah.
Command Shift 4.
Is that what it is? Command Shift 4? Is
Yeah,
that a
on
Mac?
Mac. Mm-hmm. Yeah, I took a picture of it.
Isn't there one where you crop it?
Mm-hmm.
And that's not Command Shift 4?
Well, when you crop it, I don't know how to do that. I know.
It's something like Command Shift 4.
Mm,
Command Shift 4 for you is just screenshot only?
I think so.
You didn't have to drag across of what you wanted to capture?
Oh yeah, I did do that. Yeah.
That's a crop. Yeah, that's better than a
That's-
screenshot.
Yeah.
Yeah.
All right. Thank you, Mr. Rosenthal.
You bet. Anybody else have any questions for me before we go off on break?
This is about the test. So is it going to be the same thing where you're going to put a PDF on and then?
Yeah, I'm going to basically put another test version. So it's not the same exact, but it really is very similar to test version A. And it's going to just going to show up in there at 250. And then you have till 4:30 to submit it. And then after 4:30, I'm taking it off.
Okay. And then we either print the test out or we just like write the answers on another sheet of paper?
Yeah, and you need to show all your work.
Yeah.
Because I have some students already, they're sending me stuff and they didn't show their work.
Oh.
So those students are going to have a rude awakening when we come back.
Mhm.
I cannot accept their tests and they're going to have to make it up after we come back from break somehow. And I'm afraid it's going to be a lot of students.
So it's going to be basically the same thing that you told us about the regular test?
Yeah, but even more so now because this test security is gone it's decreased a lot because I am not in the room with you.
Mm-hmm.
So I have no idea what's going on your side of the world.
Yeah.
On your side of the screen. Okay?
Yeah. Thank you, Mr. Rosenthal.
You bet. Any other questions?
Can we do future homeworks if you post them?
Well, I'm not posting them, but they are going to be in the lessons that are in Schoology. I don't recommend it because I didn't teach it yet. I'd rather get you the deeper understanding before you do the practice problems. It doesn't mean you can't do them. You can even do them correctly, but you would be doing them without the deeper understanding. The deeper understanding comes in the kind of questions we did today. Notice we did none of 9-4. We only did the deeper understanding leading up to it, right? And all of the lessons have that. And so you would be going ahead and doing problems with a shallower understanding. So you can do that. And then when we talk about the deeper understanding, that might be a different way to go about it. I think you're welcome to do that. Yeah.
Okay.
Anybody else? Anyone?
Wait, Mr. Rosenthal?
Mm-hmm.
Wait, so for the 1 over a plus b plus 2 over c plus d, so after you multiply a plus b over a plus b and c plus d over c plus d on both, on like one and like on both sides kind of like of the plus sign. So on the top.
Okay, let me just correct that way of thinking about it.
Yeah.
It's not like an equal sign where I'm doing something on both sides.
Yeah.
This is
you're multiplying by 1.
Two totally different properties. Yes. This property I'm using is the identity property. The other properties that I use for equation solving, those are properties of equality where you do it on both sides. This one has to do with that I'm multiplying by 1.
Identity.
Yeah, it's the same thing you do when you want to add those.
Yeah.
You're getting a common denominator and you're multiplying by this and by that.
Yeah, I just
Same
like,
exact thing. Yeah.
I just like forgot that it was like 1. But so on the when you multiply by 1 on like when you multiply by 1, then you get on the numerator you get c plus d plus 2a plus 2b. And on the bottom, I'm a bit confused.
You can leave it in that form. A plus b times c plus d, and this is a plus b times c plus d.
Oh.
It's like 7 times 8 and 8 times 7. They're both 56 if you multiply them out. But that would be the same as me leaving it like that.
Yeah.
What if I didn't multiply them? It's still 7 times 8 and 7 times 8. It's still the same denominator. What happens when we add fractions with the same denominator? Do you add the denominators?
No, you add the numerator.
You just add the numerators, which is what this is showing. The denominators, it's just you write it all over 56, right?
Okay.
So in this case, you just write it over the product of the two. It's the same in both cases. So it's just A plus B times C plus D.
Okay.
Okay? Any other questions? If I get kids, I will exaggerate the corona so much. I don't understand that. That was a private comment and I didn't get it. Anybody else? Questions?
So when you factor A plus B times C plus D, you would get...
Well, it's already in factored form. It's written, what is factored form? It's written as a product of two factors.
When you put it back in its...
When I expand it.
When you expand it, it would
This
be...
would become AC
C plus AD
plus BC
plus BD.
Mm-hmm.
So after that step, so you would cancel... Or would you would...
How do we cancel things? Things that are connected by addition can be canceled?
No, only things connected by
multiplication.
Multiplication.
Yeah.
Mm-hmm.
So once you have an addition here, you cannot cancel out that D with that D.
Yeah.
Because it's this D over all of this.
Mm-hmm.
It's this C also over all of this, separately.
Yeah.
Separately, it's 2A over all of this, plus separately, it's 2B over all of this. And remember that if I have the fraction 6 over 6 plus 1, you might see that, oh, can I cancel those 6s?
No.
No, because it's really 6 over 7.
7.
They don't have common factors. That would mean you could reduce any numbers, right? If you could do that, you could say, oh, I can reduce 6 over 7. Because I can break the 7 into 6 plus 1, then I would be able to reduce it. And we know that you can't do that.
Yeah.
Right? So once you have these plus signs, you cannot cancel things out. That is why we leave it this way.
In factored form.
Yeah, because these are connected. And if an A plus B combo shows up in the top, then I can cancel it.
Yeah.
Yeah. If there's an A plus B, if I end up somehow getting, for some other problem, what if I got that?
Then you can cancel.
And my final answer would be A plus D over A plus B. And I can't cancel the A's.
Because they're being...
it's added to D. Yeah.
So you would leave it as the quadratic.
This answer here, it would be A plus D over A plus B. And you can't do anything with that. You can't cancel out the A's. Because again, that would be like me having 6 over 7 and saying, well, this is 5 plus 1 and the other one is 5 plus 2. So let's cancel out the 5. So 6 over 7 is the same as 1/2, right? Which is ridiculous, right? So you can't just pull out an A and an A by addition and then cancel them. Okay?
Yep.
Right. And then that green book, if you could find that online to get your own set, you're going to be able to, you're going to really know algebra going into algebra.
Yeah.
Yeah. Okay?
Yep.
I don't know what you're going to do next year.
Yeah.
Yeah, you're going to get bored. You're going to have to be asking, hey, can I test out of algebra?
Wait, you can do that?
No, we don't. Our
Yeah.
school doesn't let students do that. So then you're going to give yourself a dilemma. You're going to put yourself in a situation where, you know, it's going to be tough for the school to differentiate for you.
Mm.
Yeah. But let's go for it. Let's keep going forward and see what you can achieve.
Yay.
Okay. You know, you can always come to me and we can continue this sidebar education throughout your time here at Science Academy.
Yep.
Okay. And then there will be opportunities to advance and then put you back on the where you're actually learning in the classroom where you're at.
Yeah.
Okay.
Okay. Thank you, Mr. Rosenthal.
You betcha.
Have a
Anybody else?
nice spring break.
You too. I think we all need to relax.
Yeah, it's been crazy.
Yeah. I can't wait though to get back, but also I'm looking forward to relaxing a little bit.
Yep. All right. Thank you.
Okay.
Bye.
I got it. All right. Anybody else? All right. I'm going to go ahead and end that meeting. I'll see you guys after the break.